In this lesson, we are going to take a look at some more specific materials. Let's open the project file and go to the Materials tab, then add a new material. This time, we'll choose Blend. The Blend material is a very powerful tool that allows you to combine different V-Ray materials to create more complex shaders. As you can see, it only has a few options. First, you will need to specify a base material, so let's use Paint Blue. Now let's apply that material to the bird figurine and start an interactive render. You can also set a render region around the bird to get faster feedback. Now let's blend the base Paint Blue material with another material. Back in the Blend Material options, you'll see this icon representing a stack of layers with a plus sign on top. Click on it once and let's add a new layer or coat on top of the base one. Right now, nothing changes in the IPR as we have not yet specified the coat material. This time, let's use Paint Red. As you can see, we get a mix of the red and blue materials, resulting in a purplish one. Let's use the slider to change the opacity of the coat layer. Black means 0% opacity, while white means 100% opacity. You can have as many layers as you want, as well as add materials of any kind to them. Each layer you add is going to blend with the result from the ones below it. To remove a layer, simply click on the small X sign. Of course, you can also use textures to define the blend amount. Click on the texture slot next to Blend, and let's use a checker texture. As you can see, now we are using the black and white information of the texture to do the blending. The black squares of the checker expose the base material, while the white squares reveal the coat material. If we use a gray color value somewhere in the middle, we then get a mix of both materials. Next, let's substitute the checker texture with a fall-off one. The fall-off texture allows you different colors based on the angle of the camera. When used to blend materials, you can achieve a wide variety of results, from chameleon paint to covering objects with snow. Let's use the fall-off to add a reflective clear coat on top of your material, simulating varnish. Try swapping the paint red material with the metal material, since it is quite reflective. Ideally, you'll want to use a perfect mirror-like material to create varnish. Now, let's substitute the fall-off map with another procedural texture. This time, let's try curvature. The V-Ray curvature texture samples information about the topology of your object, which can be used to mask different areas of it. Getting the right values is usually a matter of trial and error, so I'm going to use some settings that I already know will work for our scene here. Set the sample spread to 0.3, the max output color to 30, the scale to 2, and let's use 0.18 for the threshold. As you can see, we've now effectively isolated some parts of the bird figurine, which we can use to test different material combinations. For example, we can set a porcelain material for the base and a gold material for the isolated parts. For the next example, let's set the coat material to paint blue and the base material to iron dirty. This time, we are going to use a bitmap for blending between the materials. Let's choose the rust mask file from the assets folder so that the blue paint appears where the mask specifies it to be on the object. Now let's also create an edge between the paint and the underlying iron base. To do so, we are going to use the V-Ray bump material. This material makes it possible to apply additional bump maps to other materials. Let's put our blend material in it and apply the bump material to the figurine. Then, in the blend file, let's copy the rust mask we've used to do the blending between the materials and paste it in the bump map texture slot. What this is doing is making the bump map apply specifically to the areas where the blue paint is on the object, so that the base coat appears smooth underneath the rusting paint. However, the effect is now way too strong, so let's reduce the amount to 0.3. Okay, now let's explore another material. Let's create a stochastic flakes material and apply it to the figurine. This material can be used to simulate things like car paint, snow, and other types of glittery materials. It works by simulating at render time the aggregated effect of a large number of mirror-like flakes, which are scattered over the surface of an object. Let's change its color to a shade of blue and try out some different values for the highlight glossiness. I will use 0.6 on that, just to blur the reflections a bit more. Let's also explore the actual flakes layer. First, you can turn it on and off just to see its contribution. Next, you can specify the way the flakes are projected on the surface using the mapping type parameter. You can use the mapping channel mode and rely on UVs, or simply use triplanar mapping, which doesn't require any UVs. Next, play around with the count parameter. The actual count generated in the flakes texture is equal to that number multiplied by itself. Note how higher values make the flakes denser, while lower values make them scarce. With the scale option, you can control the tiling of the flakes texture. When the mapping type is set to mapping channel mode, you'll most likely want to set the scale to 1. For triplanar mode, the scale should usually be kept quite low, such as 0.01. Using the angle parameter, you can control the softening of the flakes effect. Lowering this value would make them sharper. There are also some other mode options for randomizing the color of different flakes. For example, you can use random hue mode to automatically shift the hue of the different flakes, or use random from map to randomize it based on a map. Next, let's stop the render and switch to the carpet close-up view to take a look at the hair material. Now let's use the carpet in our scene to showcase the hair material. Open the asset editor, and in the material list, let's add a hair material. We have to link that material to the fur, which is listed as a V-Ray geometry in the Geometry tab. Go ahead and expand the flyout menu, and in the Material section, choose Hair from the menu. Then let's enable the fur carpet geometry. If we start the APR, we will see the carpet populates with thick fur-like strands. Now let's go to the Material tab and tweak the hair material settings to add more variety to the carpet's appearance. Let's pick a more desaturated brown color and brighten it up a bit. The primary specular color affects the specularity's hue. The darker the color, the less specular the hair will look. With the primary specular's amount slider, we can control how much we want that specular color to affect the hair. The transmission color, on the other hand, will affect the color that escapes the hair strands. And in this way, we can give the carpet a more varied look if we wish. The transmission amount parameter will make that color more saturated and intensified. We can also change the glossiness of the transmission color effect, along both the length and the width. Now let's go ahead a bit further and apply a bitmap texture to the diffuse color. Let's use the abstract carpet diff file from the assets folder. We can also affect the specular color by applying a bitmap texture, just as we did with the diffuse color. Choose the abstract carpet hair spec file, and then increase the amount to 0.7. Finally, we want to be able to control the transmission color, so let's apply a third bitmap texture for that color, and choose the abstract carpet hair transmission file. Now, let's stop the interactive render and do a production render using high quality to better see the final result of the changes we made to our carpet's fur strands.